Hi students. Okay, in the previous class we have discussed about definition of current and how the current flows in a conductor in a microscopic level. We have already discussed that here, and we have discussed the formula of current also. In that, average current and instantaneous current formulas we have discussed, right? So average current I can be written as delta Q by delta T, which is nothing but the total amount of charge which is flowing through unit time is called average current. And if we write that as instantaneous current, then I is equal to dq by dt. And SI unit also we have discussed, that is amperes. And current is a scalar quantity, it's not a vector quantity. Though it has both magnitude and direction, it does not obey vector laws of addition. That's why it is said to be a scalar quantity simply. Understand? So now let us discuss two problems based on the current. Okay, so first of all, this is, suppose in a conductor certain amount of charge is flowing through a cross sectional area. Let us say that is Q is equal to, it is given as some 2t square plus t. Now we have to find out, so this much amount of charge is flowing through that cross sectional area, and it is depending upon the time like this. So Q is a function of time. So we need to calculate how much amount of current is flowing through it. Okay, exactly after 2 seconds, let us consider. So now find current flowing through it. Current flowing through it at t is equal to 2 seconds. Let us calculate. Exactly at t is equal to 2 seconds we have to calculate. So for that, if we want to write the formula for I here, it's an instantaneous current. Why? Because exactly at 2 seconds we have to calculate. So it's an instantaneous current. It can be written as dq by dt. Okay. So now what we have to do? D by dt of Q value we have to substitute here. It is 2t square plus t. Now we know the rules for differentiation here, the formulas of differentiation. So from that, then we can write it as 2 into d by dt of t square is nothing but 2t. Okay. And d by dt of t is 1 here. So from this we can get it as 4t plus 1. Now from this, exactly where he is asking to calculate the current here, exactly at 2 seconds. Therefore at 2 seconds, at t is equal to 2 seconds time, if you want to calculate that, so therefore it becomes I is equal to now in 4t plus 1, instead of t, if we substitute 2 seconds, what do we get? 4 into 2 plus 1. 4 into 2 is 8 plus 1, which is equal to 9 amperes. This is one type of problem. Okay, here we are calculating instantaneous current. Understand? Now for example, suppose one more type of example, same. In the same question, suppose if he is asking the average current from t is equal to 0 seconds to t is equal to 2 seconds. Now what we have to do? There we need to calculate the average current. Okay. So now let us discuss one more type of problem here. Suppose in hydrogen atom, I think in the chemistry you might have known about hydrogen atom. In that it consists of only one electron which is revolving around the nucleus. Okay. So let us suppose if such that nucleus in that hydrogen atom, suppose if an electron is revolving around the nucleus, let us consider this is that electron which is revolving around the nucleus in a circular orbit. Okay, and the angular frequency of revolution of the electron, the angular frequency of revolution of the electron is given as 6.25, or else let us consider it is 6.5 into 10 to the power of 15 revolution per second. Let us consider like this. Okay, it will be 6.25 only. 6.25 into 10 to the power of 15 revolution per second means this is the angular frequency given of an electron which is revolving around the nucleus in a circular orbit. Now, if we want to find here, find the current produced by that electron. Find the current produced by that electron. How much amount of current will be produced with that much of electron, with that electron. Okay. So in order to find that, we know the formula here. I is equal to Q by T simply. Understand? Now here by T means 1 by T, we can write it as Q into 1 by T means we can write it as F, where F is a frequency. Omega is angular frequency and F is a linear frequency here. So that's why if we want to convert this F into omega, then actually we know the formula omega is equal to 2 pi f, angular frequency is equal to 2 pi into linear frequency here. So from this, if you want to find F, F is equal to omega by 2 pi. Omega by 2 pi here. Now, we can find the current now. I is equal to Q. What is Q? Only one electron is there. So, the charge of one electron already we know. What is that? 1.6 into 10 to the power of minus 19 coulombs into, what is omega here? 6.25 into 10 to the power of 15 by 2 into pi value 3.14. Got my point on it? This much of amperes current is flowing through the, this much of amperes of current will be produced by that electron. Understand? So this, like this, we have to find the flow of current. Okay. Now this is about a certain problem. Suppose in this question itself, suppose if Q is not given and I is given. Let us discuss that type of problems now. Suppose if some amount of current is given, assume that I is equal to 4t plus 2. I is equal to 4t plus 2. Means here current is given as a function of time. Means suppose at t is equal to 0 seconds, then the current flowing through the conductor is 2 amperes, like that. Now, if this is a current flowing through the conductor, we need to calculate how much amount of, or here find the charge flowing through the, find the charge flowing through the conductor in 2 seconds. Find the charge which is flowing through the conductor in 2 seconds if we want to calculate. Then what we have to do? See here I is there. I can be written as dq by dt. So from this, dq is equal to, this is an instantaneous current. So from that, what can we write? dq is equal to, if we send this dt to this side, so that it will become I into dt. I into dt. Now we know the value of I here. I is a function of time, which is written as 4t plus 2 here into dt. This is dq. Now if you want to, this is what some dq amount of charge. Okay, now if you want to find the total amount of charge which is depending upon the time here, then what we have to do? Integrate on both sides here. If we integrate on both sides, then from where to where we have to calculate? Initially assume that initially the charge which is flowing through that is 0 to q. Okay, and it is 0 to 2 seconds. 0 to 2 seconds. Now integration of dq is nothing but what? Q. So that total amount of charge is q here. That q is equal to 4 into integration of t into dt can be written as t square by 2. T square by 2 here. And the limits are from 0 to 2 here. It's a definite integral. Plus 2 into t here. Limits are from 0 to 2 here. Understand? Now 2 ones, 2 twos. So q can be written as now. Q can be written as 2 into, instead of t, if we substitute 2 here, 2 square is nothing but 4. 4 into 2, 8. Okay? 2 square into 2. 4 into 2 is 8 plus 2 into 2 is 4 plus 4, which is nothing but 12 coulomb. Understand? 8 plus 4 is 12. 12 coulomb of charge. See, 12 coulomb of charge is very bigger. Actually, 1 coulomb is very bigger. Bigger amount of charge. 1 coulomb is. At 12 coulomb of charge is very huge amount of charge. Okay now. So this is how to find the total charge which is flowing in 2 seconds. Understand? So this is how we have to follow the problems. Now let us discuss one more topic. Let us discuss one more topic here, that is current density. Current density. Current density means what? Density word, it indicates that we are calculating that physical quantity with respect to, per unit area or per unit volume or per unit length, we are calculating like that. Then only we can use a word called density. Okay, so current density is denoted by the letter J here. J, small j, right? So what is current density here? Suppose inside the conductor, what did we discuss in the previous class is, inside this conductor, if we take a particular cross-sectional area, if there is a net electric field inside the conductor, there is a net electric field inside the conductor, and the electrons which are inside that, free electrons which are inside that, will move opposite to that of the electric field. The electrons which are moving opposite to that of the electric field here, not straight actually, they'll go in a random manner, but we are showing the direction of drift velocity here. So the electrons are drifting opposite to that of the electric field here. Now if we consider the area here, then how much amount of current is flowing through this area, or how much amount of charge is flowing through that area, that if we want to calculate that. For example, now if we take a particular, if we take an area here like this, okay, this is a book. Now if we just keep outside, when rain is falling vertically, okay, so when rain is falling exactly vertically, if we keep the book like this, or if we keep the book like this, means perpendicularly, it's like this. So in these two situations, in which situation we can say that this book is completely wet, means so many water drops fall on this only when the book is kept like this. Am I right or not? But if we keep the book like this, okay, then it won't get wet. Am I right or not? So like that, it depends upon the area. See here, in the same way, if we consider a particular cross-sectional area like this is a conductor now. Okay, now this area, through this area, how much amount of current is flowing? Let us consider that current is a di, or else take it as delta I. So some delta I amount of current is flowing. Okay, and here the direction of this area here, let us suppose this total area is nothing but delta S, and some amount of current is flowing through this area. No, see here the direction of area is considered to be like whenever it may be. What is the direction of area? Actually area is not a vector quantity, but infinitesimal value of area can be considered as a vector quantity, which means that ds is an area. If ds is an area, then it is a vector quantity, and the direction of that vector quantity is nothing but outward drawn unit normal. Outward drawn unit normal. For example, if this is the area, okay, if we are considering a ds amount of area, then the direction of it is exactly outward drawn unit normal, like this. What my point? Suppose if we keep like this, then the direction of this is like this. Okay, so even here also this is, let us take this as ds into n cap, where n cap is nothing but outward drawn unit normal. Okay, so this is the area direction. Now how much amount of current is flowing in this area? That is called as current density here. Means current density can be defined as the amount of current flowing through unit area is called as current density. So we can write it as J is equal to or J bar is equal to delta I by delta S, where delta S is nothing but what? Area. If we want to write this in a perfect vector form, then actually current is not a vector, no. So we can write, suppose if we write that instantaneously, then we can write it as di by ds. Here. So di can be written as J bar dot ds bar. J bar dot ds bar here. Means we are going to take the dot product of these two. Why? Because we are calculating how much amount of current is flowing along the direction of this area. Okay, or see here we are taking the dot product of these two. So finally we will write it as J into ds into cos theta. So from this we can easily say, suppose if the area is like this, if we are considering the area like this, suppose if the current is flowing through this area like this, exactly perpendicular. Got my point on it? Then what is the angle between what we say current density and area here? What is the angle between current density and area here? The current density and area direction is this only, and the direction of current density is this only. Means either it will be 0 or 180. Am I right or not? So if it is 0 or 180, so much amount of current will be flowing through this area. But if it is given like this, then no current. Why? Because the direction of area will be like this, and the current which is flowing through this is like this. What is the angle between current density and area here? 90 degrees. If we keep like this, then if the current is flowing through it like this, then the angle between the current density and the area is 90 degrees. So that's why if theta is equal to 90 degrees, then what happens? No current flows through this, or the current density, or no current flows through this. See here, if theta is equal to 90, then di is equal to cos 90 can be written as 0. So everything is 0. Means if we keep the area perpendicular to the direction of current, flow of current, here we just say the direction of current density will be always along the direction of current only at that instant. Okay, so that's why di is equal to 0 here. And if theta is equal to 0 here, then di will be maximum here. Maximum means J into ds. Di will be maximum, that is J into ds here. Okay, and what is the SI unit of this current density? Current density SI unit is, see here, I means amperes and S means meter square. So that's why we can write it as ampere per meter square. What is the SI unit of it? Ampere per meter square. The SI unit of this current density is ampere per meter square. Okay. So it's okay. Let us discuss in the next class about drift velocity of the electrons. Okay. Thank you.